Now the third one is the time reversal operation. The third one is a time reversal operation. So time reversal simply means that it is just like a mirror image. For example, if I am having a signal which is something like this, -1 to 1, this is my signal f of t. Now time reversal means that replace t with minus t. Replace t with minus t. So whenever I replace t with minus t, so then the resultant signal will be f of minus t. And f of minus t will be something like this. Okay. So this is what is nothing but a mirror image. See, whenever you see a right-handed batsman in a mirror, how it looks like? Whenever you see a right-handed batsman in a mirror, a plain mirror, then you observe that he looks like a left-handed batsman. Correct? So same thing is going to happen here. So whatever information is present on the left side, that comes to the right side, just it superimposes onto the right side. It just superimposes onto the right side, and whatever information you are having on the right side, that comes to the left side. Right? So this particular operation is what we call as, this sort of transformation is what we call as a time reversal operation. A time reversal operation. Right? So one of the very interesting application of this particular time reversal is whenever we are moving back and forth. Whenever we are moving our video back and forth, there we use this particular application of time reversal. For example, a batsman is run out and we are checking whether he is actually run out or not using the third umpire system. Right? So then what the third umpire does? He goes up, he goes back, he goes up, he goes back. So in this particular case, he will be using the concept of time reversal. So how the time reversal is happening here? So whenever he is moving like this, forward, and whenever he wants to go back, what he will do is that he will just apply time reversal, he goes forward only. Instead of moving backward, he will just apply the time reversal and he goes forward. And when he goes forward after applying time reversal, actually he is going backward. Okay, so if this is your actual information, if you are going forward and if you wanted to go backward, so what you will do? You will not go like this, but what you do is that you apply the time reversal operation. You apply the time reversal operation and then go forward. Then what you are actually doing is you are actually going backward. So whenever you wanted to go back and forth, then we actually use this particular concept of time reversal. So time reversal is a very simple operation. Now, so for the signal that we have discussed before, -1 to 2 f of t, we have to find or plot, let us say plot f of 3t minus 2. F of 3t minus 2, the first operation is, of course, the standard operation, shift, then scale, and then reverse. Shifting, scaling, and reversal. The second we are going to do is we are going to start with scaling, then shifting, then reversal. And third is we do reversal and then shift, and then scale and then shift. In fact, we will change the second approach because we have already seen scale shift. We have already seen scale shift in the last case. So let us do reversal shift. Right. So please quickly take the question and try to solve it. I think the first one is very simple. The first one is very simple. F of t becomes f of t minus 2. apply the shift of 2 units. So when you apply the shift of 2 units, what happens? Plus 2 plus 2. So it goes from 1 to 4. The signal will be from 1 to 4. This is f of t minus 2. The second thing that we are going to do, f of t minus 2, we are going to apply the operation of f of t becomes 3t, scaling operation. So that you replace t with of 3t, it becomes f of 3t minus 2. So what happens? Divided by 3 and divided by 3. So the resultant signal now becomes 1 by 3 to 4 by 3. Right? Acha, so we haven't taken a reversal in this case. So we will also take the reversal. Okay? We will also take the reversal. So the last operation is f of 3t minus 2. T becomes minus t. F of minus 3t minus 2. Right? So what I am doing here? Just replacing t with of minus t. If I replace t with minus t, what will happen? Okay, it's going to become f of minus 3t, and of course this is untouched, so it is going to become minus 2 only. So the simple operation that I am performing here is the time reversal. This operation is what we call as time reversal. So when we do this, the information will go something like this. Okay, so the resultant signal will be what? Minus 1 by 3 to minus 4 by 3. So this is f of minus 3t minus 2. So there is a small change here. We are indicating the reversal. Previously the reversal was not there. Next operation, next approach is first reversal. First reversal is a very simple operation. Starting with reversal, f of t becomes f of minus t. With the transformation of t becomes minus t. So we are operating on the very first signal, which is f of t. So when you do that, the information which is present on the right side will come to the left side. The information which is present on the right side will come to the left side. So it would be something like this. Okay? Minus 2 to the value of 1. Minus 2 to the value of 1. This is f of minus t. Now, f of minus t, f of minus t, next operation is scaling operation, sorry, shifting operation. So, we didn't do the scaling yet. So, the scaling operation will not be there. So, without scaling operation, this is the result that you want. Okay? So, without scaling, the operation is that f of minus t minus 2. So, f of minus t minus 2. See, if you blindly follow this particular thing, that there is a minus 2 here, so what I will do is t becomes t minus 2. This would become a mistake. If you blindly do this particular thing, that t becomes, because there is a minus 2 here, so what operation I am going to do is t becomes t minus 2, it will be a mistake. Why? It is because of the fact that if you actually do this particular thing, then what will happen? Minus of t minus 2. So it is going to become f of minus t plus 2. But what you want? You want f of minus t minus 2. So what is the operation that I have done before that I am going to take as common? Right? So this is the result that is desired for us. This is the result which is desired for us. So the operation that I have done before is a reversal. I will take it as common. So if I take it as common, okay. So whatever operation that I have done before, I will be taking it as common. And now this will indicate the amount of shift which is required for us. This will indicate the amount of shift which is required for us. So it is actually t plus 2. It is actually t plus 2, where plus indicates the advancing operation and 2 indicates the amount of shift. So here advancing is moving towards left. The best way of moving towards left is subtracting time. the best way of moving towards left is subtracting time. So if I subtract time, then it is going to be from minus 4 to the value of minus 1. It will be from minus 4 to the value of minus 1. Minus 4 to minus 1. So this is what we call as f of minus t minus 2. F of minus t minus 2. The game is not yet over. The last operation is pending. So from f of minus t minus 2, the result I want is f of minus 3t minus 2. Isn't it? The result that we want is f of minus 3t minus 2. So here there is no, I can directly blindly go by this. The scaling parameter is going to be 3t. So you can blindly follow whenever you are doing the reversal operation and scaling operation. But whenever you are doing shifting operation, you should not blindly follow, especially if you have already done the operation before. If you have already done reversal or scaling before, or both of them before, then whenever you are doing the shifting, you have to be very, very careful. But whenever you are doing the scaling or reversal at any point, it doesn't matter, it is not going to change, we can blindly do it. Right? So here, if I do the shifting if I do the scaling operation, divided by 3, now it is going to be actual, what we got in the previous case, or the previous approach. So from minus 4 by 3 to minus 1 by 3. Minus 4 by 3 to minus 1 by 3. This is what we call as f of minus 3t minus 2. See, we have already got f of minus t. And what we wanted to get after doing the shifting operation, what is the result that I wanted to get? How should I get to know that this is the result I wanted to get? Is that this is what we have to actually plot. This is what we have to actually plot, but we are not doing scaling in this step. We haven't yet done the scaling in this step. So the result that you are looking after completing this particular operation is f of minus t minus 2. Is this clear to you? How we got this f of minus t minus 2 as a desired result? Did you understand this? Very good. Now, if this is what you require, then the mistake that we generally do is that seeing a minus 2 here, we directly go for t becomes t minus 2, which is a delay operation. But if you do that, then you have seen what is going to be the problem, that if you do that t becomes t minus 2, then what will happen? You will replace t with the of t minus 2. Okay, if you replace t with the of t minus 2, then you will be having f of minus t plus 2. But the result that is required for us is f of minus t minus 2. So what I told in the previous case, in the previous problem, holds good for here also. That whatever operation that you have done before, whatever operation which is reversal that you have done before, that you have to take it as common from the previous result. Okay. Now whatever amount of thing that you are going to have, time you are going to have, that is what the amount of shift which is required for us. Okay. So because we have already done the reversal, so I am taking the reversal component as common. I am going to take the reversal component as common, and this should be the amount of shift that I have to do. This should be the amount of shift or operation that I have to do. So I have selected t becomes t plus 2. Right? So now let us go for the third approach. Even in the third approach, we will start with reversal. So till here we are going to be the same thing. Right? So we have completed the reversal here. Then we are going to do the scaling operation. Right? Because we haven't done the shifting operation. So what is the result for us which is required after doing the scaling operation is that f of minus 3t. F of minus 3t is what is required in this step for us. I told you if we can blindly go with this, that t becomes 3t. So when you do this, then you are having a scaling parameter of 3. So whenever you are having a scaling parameter of 3, what is the approach? We just divide the time axis by the scaling parameter. We divide the time axis by the scaling parameter. So when you do that, it's going to be minus 2 by 3 to the value of 1 by 3. Minus 2 by 3 to the value of 1 by 3. This is the result which is f of minus 3t. This is the result which is f of minus 3t. So from now, f of minus 3t, I want f of minus 3t minus 2. From f of minus 3t, I want f of minus 3t minus 2. So whenever I want this, what is the operation that I have to perform? I have already done the reversal, I have already done the scaling before. So whatever I have done before, that I have to take as common. Whatever I have done before, that I have to take as common. Right? So now the operation that I have to perform is t becomes t plus 2 by 3. Right? So it's an advancing operation. Isn't it an advancing operation? It's an advancing operation. Right? So plus indicates an advancing operation here. So when I advance it by 2 by 3, if I advance it by 2 by 3, so it will be from minus 4 by 2 3, minus 4 by 3 to minus 1 by 3. Right? And once again, it is matching with the result that we got when we have done shift, scale and reversal. So we are very happy with this. Right? So the point to learn for us is that if you have f of at and if you want f of at plus b, the approach is that to take whatever you have taken common. So this will be the amount of shift. If you have done with scaling and if you want f of minus t plus a, okay? So whenever you have done the reversal, in this step you are doing the shifting and the result that you want is f of minus t plus a. Then because I have done the reversal before itself, so I'll take the reversal outside. So it is going to be something like this. So t becomes t minus a. Right? So the last step is that if I have done both before itself, correct? So if I have done both reversal as well as scaling before itself, so what I will do, I will take both of them as common. Is this concept clear to all of you? Shifting, scaling and reversal operation that we have performed on the time. Right? See, let me quickly tell you, there is something called as, this is not important in the examination point of view, there is something called as transformation of dependent variable. We have transformation of dependent variable. Okay, there is something called as transformation of dependent variable. So dependent is what? Which variable is dependent? Can you please tell me? We know time is an independent variable. The amplitude or the signal, yes, very good, f of t. The signal itself is going to be a dependent variable. Okay, so we can also have a shifting, scaling, reversal here. So here we call it as shifting, scaling, reversal here also. But this will be what? This will not be time shift, time scale, time reversal. It will be amplitude shift, amplitude scale, amplitude reversal. For example, if I have a signal, let us say there is a signal called as something like this. Okay, minus 1 to the value of 1. This is my signal f of t and let us say the amplitude value is 1. Okay, so now when I am going to add amplitude to it, right, f of t plus 1. If I add plus 1, it means that I am adding a DC component, isn't it? 1 is something like this, yes or no? 1 is something like this, the DC component. So when you add 1 to it, then what will happen? The amplitude will be raised by 1 unit. The amplitude will be raised by 1 unit and the remaining signal is going to be something like this. So this is what we technically called as DC shifting or clamping operation. Technically we call this particular operation as a DC shifting operation or a clamping operation. So whenever you are varying the DC component which is present in the signal whether you are adding the DC component or you are subtracting the DC component, this is what we call as a clamping operation, and here we can call it as amplitude shifting. Here we can call it as amplitude shifting. So in this way, you can either shift it towards up or you can also shift it towards down. You can either shift it towards up or you can shift it towards down. Okay, it's completely up to you. So this is what we call as an amplitude shifting operation. The second operation that we are performing is amplitude scaling operation. So amplitude scaling means f of t is converted to a times the of f of t. F of t is converted to a times the of f of t. So here we are multiplying the signal by a scaling parameter. We are multiplying the signal by a scaling parameter. Okay, let us say this is any other parameter. Okay, because we have already used a here. Let me say that there is a k here, right? So whenever I am doing the scaling of my amplitude, the signal is nothing but the amplitude. If I am scaling my signal, this is what we call as an amplitude scaling. So if I initially have a signal something like this with the amplitude of 1, now k into f of t is going to be something like this. This will be k into f of t. Initially it is 1, now the amplitude value will be k. So this is what we call as amplitude scaling. This is what we call as amplitude scaling. The third operation that you are performing here, is amplitude reversal. The third operation that we are performing here is amplitude reversal. It means that just like the way in the previous case what we have done, whatever information is present on the left side, we have moved it to the right side, and whatever information is present on the right side, that we have transformed to the left side, correct? Now what we do, opposite. Whatever is present up, that we are going to put down. Whatever is present in down, that we will put up, right? So minus of f of t is that, now because the actual information is present in the up, now we are going to do down. So after doing that, it becomes something like this. Okay, so positive amplitude becomes a negative amplitude, and negative amplitude is going to become a positive amplitude, and this signal is what we call as a time reversed operation, amplitude reversed operation. So amplitude shift, amplitude scale, and amplitude reversal. Right. Yeah, so please look at the board. It's a very, very simple thing. Because we have already learned about time shifting, time scaling, and time reversal, I'm just casually explaining about amplitude shifting and amplitude scaling, amplitude reversal. So amplitude shifting means what? We are adding the amplitude or we are subtracting the amplitude to the existing signal. Just like the way we have done, either moving the signal towards right or towards left. True? So here we are either moving it towards up or we are doing towards down. So the signal will be moving up when you are adding the DC component. When you are subtracting the DC component, then the information is going to move down. Okay, this is what we call as a amplitude shift operation. This is what we call as amplitude shift operation. Amplitude scaling means what? Amplitude scaling means whatever amplitude you are having, the signal itself is your amplitude. So whatever amplitude you are having, if you are multiplying the amplitude with a scaling parameter, that is what we call as the amplitude scaling. In a way, we can also call it as a amplification. When the value of k is greater than 1. When the value of k is greater than 1, then you are actually increasing the strength of the signal. Increasing the signal strength is what we call as an amplification of the signal, correct? Yes or no? So the multiplying by a scaling parameter can also be called as an amplification if the value of k is greater than 1. If the value of k is less than 1, then we call it as a attenuation operation. Because it reduces the strength of the signal. If the value of k is going to be less than 1. Both ways, this is what we call as a amplitude scaling operation. We call it as a amplitude scaling operation. It means that whatever information you are having, multiplying it with k number of times, right? The third operation that we have done is the amplitude reversal operation. The third one that we have done is the amplitude reversal operation. So in the case of amplitude reversal, what happens? A positive amplitude becomes a negative amplitude, and the negative amplitude is going to become a positive amplitude. So initially we had a signal like this. Now amplitude reversal means f of t becomes minus of f of t. F of t becomes minus of f of t. So we are just multiplying it with minus 1. We are just multiplying the signal with minus 1. So whenever you do minus to it, what happens? Whatever is positive is now going to become negative. Whatever was negative is now going to become positive. Clear? So this is what we call as a amplitude reversal operation.